Okay, here we go. So we're on chapter 4, which is on scatterplots and correlation. Okay? These two topics are very interrelated with each other. Okay? So let's first talk about a scatterplot. A scatterplot is a visual representation to show the relationship between two variables. Okay? And we try, and I'm going to emphasize the word try, to put the explanatory variable on the x-axis. Sometimes that's a little bit harder to decide which one's the explanatory and which one is the response. But generally what you're doing is you're going to try to put the explanatory variable on the x-axis. You're going to try to put the response variable on the y-axis. Okay? And hopefully what you'll do is you'll plot a bunch of points. Okay? And the idea here is you want to see, I'm going to turn off this light here and see if that helps with the video a little bit. A little bit. There's still a big glare over there, but it looks pretty good. Okay? So the idea here is you're looking for a straight line. Now this would be an example of what we would call positive correlation. Okay? You could also see something that looks like this. This would be an example of negative correlation. Okay? You could also see something, that doesn't help, okay, that looks like a curve. Okay, it looks like a curve there. This would be an example of a non-linear correlation. Okay, you could also see something that looks like a big blob, right? Okay, there's no real pattern going on here. This would be what we would call no correlation. And we would refer to this as a null, N-U-L-L plot. Okay? Question?
So with the positive and negative correlations, they're linear. And so with the nonlinear correlation, it's still like that one that you drew, it's still going up. So would it be a positive nonlinear correlation?
Yeah, you can call it a positive nonlinear. That would be fine. And of course, you could have a negative as well. Okay? So the idea behind the scatter plot is you're trying to show the relationship for two variables. We hope for a straight line. I'm going to say hope for a straight line. If it's not a straight line, other than the fact that we can say, hey, that's not a straight line, it's going to be more complicated than we're going to deal with in this class. Okay? So basically, you're looking, is it the straight line? Is it not a straight line? In either case. Okay? So, all right. So let's talk about here. Let's do an example. I'm going to open up Excel, and we're going to do an example of a scatter plot here. Let me share my screen. Okay. All right. So let me ask you guys a question. Well, first of all, before I do that, I'll ask you a different question. Okay, so as you're thinking about a person's weight and how much they exercise, okay? Here, I'm going to take this off the camera for a second. Okay, let's talk about a person's weight and how much they exercise. Would your weight explain how much you exercise, or how much you exercise, would that explain your weight? Your exercise would probably explain your weight. Okay, so in this case, you would probably put weight. No, not weight. Your exercise, you would put time spent exercising based on so that would be the explanatory variable, and your response variable would be your weight. Does that make sense? Now, sometimes this isn't quite so easy to think about. So, for example, what if I said, do you think there's a relationship between how tall you are and your shoe size? Do you think there's a relationship?
Yeah.
Probably is, right? Would you think it would be a positive relationship, or would it be a negative relationship? So positive, taller people are going to have bigger feet, correct? Okay. Now, on the other hand, maybe I drew this wrong. I did. We would probably think that time spent exercising and your weight, that would probably be a negative correlation. The more you exercise, the lower your weight. Does that make sense?
Yeah.
Okay. People who exercise a lot generally weigh less. Okay. Now the question is, with your shoe size and your height, does your shoe size explain how tall you are, or does how tall you are explain how big your feet are?
How tall you are explains.
It's kind of a chicken or the egg thing, right?
How tall you are explains the shoe size.
You could argue it either way. Okay. So sometimes these are a little bit hard to figure out. The time spent exercising and the weight, that one's a little bit easier, so you should really worry about that. But let's do a little experiment. We're going to see if there's a correlation between how tall you are and how big your feet are. Okay? So let me share my screen again. Yes,
Does
Braden.
it throw it off really bad if you put it on the wrong axis?
Oh, that's a good question. We're going to do it both ways and see what happens. Okay? All right. So let's do shoe size and your height. Braden, let's start off with you. What's your shoe size?
10.5.
10.5, and how tall are you?
6 foot.
6 foot, 6 times 12 is 72 inches. Okay?
11, and then 5, 10 and a half.
5, 10 and a half, so it's 5 times 12 is 60, 70 and a half inches. Okay? Ashley?
A 7.
7.
And I'm 5'6".
5'6", so you're 66 inches tall. Okay? Colin?
I'm
I
like
couldn't remember.
9.5,
9.5,
Girl shoe size.
and I am 67 inches.
67 inches. Landon? 72 inches.
Oh, sorry. And 10.
Size 10 shoe. Okay. Let's go. Geez, I'm striking out on the second row. Tanner,
Yeah, we're at 11 and I'm 6 foot.
72 inches. And Lindsay,
6.5.
you're what?
6.5.
6.5 shoe. 63 inches. Okay. Shelby, no. Kensley,
I wear a 7.5,
7.5,
and then I'm 65 inches.
65 inches. Brenda,
I wear 8,
8,
68.
68 inches. Okay. Suzette,
I'm 8,
8,
and I'm 5'5".
5'5", so that would be 65 inches. Riley,
8.5, and I'm 5'8".
5'8" would be 68 inches. Okay. And it's Audrey.
Yeah.
Okay.
I am a 7.5.
7.5,
5'6".
66. And Jaylyn,
I'm 7, and I'm 5'2".
5'2".
Yeah.
So you're 62. And Gage,
I'm 10.5 and I'm 69.
and you're how what?
69.
69 inches. And Shire.
I'm 9, and I'm 5'11".
So 5'11", 60, let's see, 5 times 12 is 60, and 11, 71. Okay? All right. So here we go. Okay, so here's how you create a scatter plot. Go ahead and when you select these two columns, make sure you include the column heading shoe size and height, because if you do, it'll put it on the graph for you. Okay, so we're going to go to Insert, and then you're going to click on the scatter plot right here, and just pick the first one here, scatter plot. Okay, so that was nice and easy, but we need to add our axis titles. Do you remember how to do that? How?
Yeah, hit the plus.
The green plus sign, axis titles. So down here, what are we going to put? Shoe size. And over here, we're going to put height in inches.
Move this down.
Okay? And then we'll put the relationship between shoe size and height. Oh, terrible when you can't see what you're typing. Sometimes you can see what you're typing and sometimes you can't. I'm not sure why. Okay, so as you look at this, what do you think? Does this look like a straight line to you, roughly?
Yes.
Yeah, probably could draw a straight line in here, okay? Now, the thing that I want to point out here, let me show you another website, okay? If you go to Wikipedia, okay? I know a lot of people complain about Wikipedia, but for the math, it's actually pretty good, okay? So let's talk about correlation independent, okay? So here's what I want to show you guys. So here's some examples here. Oh, it even made it maximum for me. These are some examples of some scatter plots, okay? So the thing that I want to point out here is correlation kind of tells, so they've got some numbers up here. Here, I'll point to this one since it's closer. You can see that this is what we would call a perfect correlation. So if you were to correlate your shoe size with your shoe size, it should be a straight line. Well, that would be kind of silly because why would you do that? But you could, okay? Now your straight line doesn't have, so we say that all three of these that have ones on them, these are all positively correlated. These are all negatively correlated. So these are positive because it goes from low to high, low to high, low to high, and then high to low, high to low, high to low, okay? I don't know that you'd ever see a perfectly flat line. That's kind of weird, okay? But yes, we would say that these are all equally strongly correlated, okay? Now, up at the top, they've got the correlation coefficient. I'm going to show you guys how to calculate that in just a minute. But the idea here is your correlation coefficient always gives you a value between +1 and -1. And it tells you kind of how close the dots are together. So on this top row, this is perfectly correlated. This one is pretty strong here, 0.8. 0.4, not so strong. If you see this is what we call a null plot. This would say that there's no correlation. And then these are all in the negative direction, -0.4, 0.8, and 1. Now, the thing that I want to point out here, we've got a thing called a correlation coefficient. Before you ever calculate your correlation coefficient always assumes it's going to be a straight line. And the problem is, if you try to calculate your correlation coefficient without looking at the scatter plot, you can see this bottom row here. You can see that there's a pattern going on here, right? But it's not a straight line. So if you look at your correlation coefficient and it tells you that it's 0, but you don't look at your scatter plot, if it's a null plot, you can correctly say that there's no correlation. But if it's something that looks like this big W here, this would tell you that there's not a straight line correlation. Okay, so you need to always look at your scatter plot before you calculate your correlation coefficient. All this bottom row has zeros. These two look like fake data to me. This is something you could see in real life. This is a kind of a parabola. You could see something like that. This looks like two parabolas. Okay. I don't know what that is, but that's different. This looks like you've got 4 different populations scattered here. Okay. So at any rate, we're going to show you how to calculate the correlation coefficient in a minute. Let me show you one other website that I want to talk about before I show you how to calculate the correlation coefficient. And let's see if it pops up here. Oh, you turkey. Analytic Tech. .com/MB313 correlate. Oh, I spelled something wrong. Again, it's www.
Have you gotten any of the IRB forms back? Approved?
Has everybody turned them in? I haven't sent them in yet because I thought I was waiting for somebody to finish. Yeah, turn that in so that Brady's waiting.
I know, I'm really excited.
Okay, I was going to turn them all in. Make sure that's turned in. I'm glad you reminded me, Brady. I'll turn them in, but I need to turn them in by tomorrow, okay? And really by today, so that I can turn them in tomorrow. Because I've been waiting for your group because I thought somebody hadn't turned them in. Okay, analytic. Oh, that's the problem. There we go. This is the website I was looking for. Okay, so just to remind you, the correlation coefficient shows see how these are close together and these are more spread out here. So it tells you how spread out your data are. So as we go down here, here's just some more examples here. This would be an example. You're rarely going to get a perfectly zero correlation, but this is 0.03. That's very close to zero. This would be an example of a null plot. Okay. You can see 0.28. Okay. So you can see here, this kind of is in an upward direction, and it's there. Okay. This would be 0.48. You can see the dots are closer together. 0.72, definitely a straight line there. 0.89, that looks even better. 0.99, this almost makes you think they faked their data. That's really strong correlation, okay? So that's the idea behind the correlation coefficient. So let's talk about how to calculate correlation coefficient, okay? So I think I'm going to erase this because there's a big glare on the board. Okay, so the letter we use for the correlation coefficient is the letter R. Correlation, I guess. So that's your correlation coefficient. And it's always between -1 and +1. And a 0 can imply no correlation if backed up by scatterplot, which we're looking for a null scatterplot, no. Okay, so the correlation coefficient, it describes the strength of the relationship between the two variables. Okay, so I'm going to put absolute values here. If you have something that's greater than 0.7, then we're going to call that strong. If it is 0.3 to 0.7, the absolute value, then we're going to call that moderate. And if it's less than 0.3, we're going to call that weak. And if it's close to 0, then we're going to say that's no, but you need a null plot to back that up. Okay. All right, so now the formula that I'm going to give you here, you don't have to memorize this formula, but I'm going to also give you some steps, and if you want to memorize the steps, you can. I will give you this formula on the test. R equals the sum of xi minus x bar over s sub x times yi minus y bar over s sub y. all divided by n minus 1. Okay? So we're going to show you how to calculate that with Excel. And we'll do that. Now, steps that you're going to want to know. Question?
Oh, yeah.
Wait,
That's
yeah,
it.
5, is that a 5x?
No, that's an S.
5s.
Those are S's.
That's- that's it.
Okay?
Oh.
So do you remember what X bar and Y bar mean?
X. That means population mean. Yeah, population mean or just mean.
You got the mean right. You didn't get the population right.
Sample.
It's the sample mean. Okay? So the first thing you're going to want to do is you're going to find the sample mean for X and for Y. Okay? Now, so essentially this is your data minus your mean divided by S stands for your standard deviation. What does this in the parentheses look very much like? Looks a lot, well, it is the standard deviation. But I'm talking about this piece right in the parentheses. What does that, what formula does that look very much like? Very much like chapter 3, we just talked about it.
Your z-score.
It looks like a z-score, doesn't it? And that's basically what it is, okay? So that's basically what it is, okay? So find the sample mean for X and Y. S sub X stands for the
Standard deviation.
standard deviation. So you're going to find the standard deviation for X and Y. Okay. Then you're going to take this and you're going to find the z-scores for X and Y. What are we going to do with our z-scores once we found them? We're going to multiply them together. Find the product of your z-scores. Step number 5, what does this mean? Find the sum.
Is that an 8 after product, or what is that?
And the sum of the products. What are you asking me?
Is that an 8 after product on step 4, or what is that?
Find the product of your z-scores. Okay? And finally, step number 6, we're going to divide by n minus 1. Okay? So what we're going to do, and let me, so you guys think, well, we're going to figure out how to find this out, okay? And we're going to use the data from the class that we just collected. So let's share.
Sharing is caring.
Okay? So we're going to find out if there's a strong, moderate, weak, or no correlation. It looks pretty strongly that there's no correlation, correct? Okay? So step number 1 says what, Brenda? Find the mean for your X and Y. Do you remember how to find that?
Average sum.
Equals average, and then you're going to cursive Gates for using that word, right? Okay. Equals average, and then you're going to highlight all of your data for the shoe size. Oh, by the way, you know what we forgot to do? We'll do that for both of these. But you know what we forgot to do? We forgot to say what's the difference when we, in fact, here's what I'm going to do. I'm going to make a copy of this column. By the way, do not sort your data. If you sort your data, you can mess it up. Okay? Now, we're going to show you what that looks like. Now, in this chart, we said that the shoe size was the explanatory variable. Now we're going to do the height as the explanatory variable. So, Suzette, can you remind me how to do a scatter plot? So highlight your data, insert, scatter plot, boom. What do you know? And then we'll add our thing in here. So this is what? The x-axis is height in inches, and this is shoe size. Okay? And this is height and shoe size relationship. Okay? Now, what do you notice? They're both positive, right? This one has a steeper slope than this one. Okay, now, the thing that I just want to point out here is when we talk about positive or negative relationship, it's going to be, if it's positive, it'll be positive whether you have, no matter what you have as your explanatory variable. The slope might be different as it is in this case, but it will still be positive. Okay, does that make sense? All right, so I just wanted to show you that really quickly. All right, so we found the mean. Step number 2 is what, Jalen? You're in a bad spot for seeing the board. I can't hear you.
What does that say? Find
Standard deviation. Do you know how to find that quickly and easily? No. What's the cheater method? Who remembers the cheater method? STDev. Now, which one am I supposed to use? Because I got lots of choices.
The one with the exclamation point.
You can use the one, or you could also use the one with the .s, right? Because it's a sample. Either of them will give you the same answer. Okay. So I'm going to highlight my data. So we've got a shoe size. The mean shoe size is 8.76, and with a standard deviation of 1.5 shoe sizes. The mean height is about 67 and almost 68 inches, and 3¼ inches is the standard deviation.
Are you always going to do the standard deviation S, or is it just for this problem because it's a sample?
You can either use the .s or the one with the exclamation point. Either one's fine.
But can you use the exclamation?
Do not use the .p. The .p will give you the wrong answer.
Because that's for population.
That's for population.
Okay.
And you will pretty much never do this on a population.
Okay.
Okay?
Oh.
All right, so now, we've done steps 1 and 2. So Shire, what's step number 3?
Find the z-scores.
Find the z-score. So we're going to find the z-score for the shoe and the z-score for the height. Okay, can you help me do it for the shoe size? Okay. So what's x sub I in this case? What does x sub I represent? Represents your data. So what's your first data point? Shoe size, so we're going to use the 10.5, right? And then what does the formula say? Minus the mean. What am I subtracting? 8.76. And then what? Divided by, what's S? Standard deviation of x, which in this case is 1.55. Okay, is that the correct formula?
You need to do the S on one of them, so then you have that, so then you can just drag it down. Yeah?
The S?
The F4. Or
F4.
the,
Oh, do I need to
sign.
press F4 on these? Where do I press F4?
On the mean and standard deviation.
On the mean and the standard deviation. So I need to do it here, and I also need to do it there. Is the formula now correct?
Yeah.
Almost. No, it's not. I need parentheses around just the numerator, right? I need a parenthesis here. Oops, didn't mean to erase that. And I need it around the numerator, okay? All right, does that make sense?
Yes.
Okay. Now we're going to copy it down.
Wow, I love it.
Okay? Some of them should be positive, some of them will be negative. Okay? All right, so now Riley, can you help me do the same thing with the height? Okay,
Take the 72
72,
and then divide it by, or subtract it from the mean,
which mean
the 67.
the 67,
And then you divide it by this 3.2, which is the standard deviation.
3.2. Is that it?
F4 on the mean as well as the standard deviation.
F4 on both of those. Okay, is that it?
And then you put parentheses on the numerator.
Parentheses on the numerator. Okay. By the way, if you don't put parentheses, it will still give you an answer, but it will be the wrong answer. Okay? All right, so now we'll copy that down. Lindsay.
Just a reference on the test, we allowed to use the sheet for the standard deviation.
Yeah, because you guys hopefully did the standard deviation correct on the last test. You guys actually did pretty well. Oh, did I ever show you how you did on the first test?
Now that considers.
Here, we'll finish this and I'll show you in a minute. But yeah, actually the median score was like 80%, which is really good for a test. You guys were scaring the crap out of me. Thank you for studying. That was really good. Okay? I'll show you that in a minute.
Wait, mean score as well.
It was like 80. So half of you got 80 or above.
What's the standard deviation?
I don't remember. Well, we'll look at it.
We should look.
I have it on this spreadsheet. Okay, and we'll also see if you guys are normal. Do you guys think you're normal? We'll find out. Okay? All right, let's finish this up. Okay, so we found the z-scores for steps for X and Y. That's step number 3. So, Braden, what
Yes.
is step number 4?
Find the product of the z.
We need to find the products. Okay, what am I multiplying together?
Z score for the shoe size. And
Z-score for, so 1.11 times
1.28.
1.28. Okay, do I need to F4 any of these? No, do not F4 those. Okay. We are going to copy that down. And now, Colin, what's the next step?
We divide by the amount.
No, you skipped a step.
So we add these all up, don't we?
We need to find the sum. How do I find the sum quickly and easily?
You hit that auto sum, right?
Auto sum button. Now, by the way, I'm going to mention, do you notice how I put a blank space between the data and my totals? You should do that too, because some of you won't, and then you'll mistake your data for your totals, and then you'll mess up. Okay? So we're going to add up that. Okay? And then what next, Lindsay? N minus 1. So here's my question to you all. If I highlight my data here, is my N 15 or 30? 15 or 30? What's my N?
Your N is going to be 15.
15 pairs, right? Because you've all been measured twice. There's only 15 of you in the room. There's not 30. Okay? So we're going to divide by what number? 14. Whoops. Let's try that again. That number divided by 14. Okay? And I got 0.867. So, Landon, would you say that's strong, moderate, weak, or no correlation?
That is strong.
You'd say that is strong correlation. Okay? So let me ask you another question. Do you think that Excel knows how to do this an easier way?
Probably.
Do you think I'll let you use that on the test?
No.
You can check yourself, but yeah, how many points do you get? 0. Okay, some of you did that on the standard deviation on the last test, and how many points you got? 0. Okay? So if you were Bill Gates and you were going to do a double check, and you were going to try to think of a command for the correlation coefficient, what would you call it? Correlation, how about that? C-O-R, how about coral? Okay? Coral. Now this one's a little trickier to use, but it's not bad, okay? It says array 1, that means your X data. So I'm going to click on my X data, and then I'm going to click on, hit a comma, and then I'm going to click on my Y data. Okay? And I press enter. I got 0.867.
Oh my gosh, it's awesome.
Do you guys feel as smart as a computer now? Okay.
Man, if I could do it that fast, maybe.
All right. Okay. Now let me ask you another question. What if I put the height as the X variable and the shoe size as the Y variable? Will that change my correlation?
Yeah.
Should we find out? CORREL. Okay. I'm using the height as my X variable and the shoe size as my Y variable. Drum roll, please. Exactly the same.
What the heck?
Your correlation coefficient doesn't care. Okay? Your scatter plot cares because look at your slope. Your slopes are different, but the correlation coefficient says, yeah, they're strongly. Remember, it measures the dispersion of the dots, not the slope. It's not the slope.
Obviously, if I would have thought about that, I would have.
So your correlation coefficient does not care. Now here's another thing it doesn't care about. Do you notice that this is shoe size and this is height? Those are completely different units. Okay? When you standardize your scores, you lose all your units. Okay? So there are no units with correlation coefficient. It's just a value. Does that make sense? Okay? Questions? How are you feeling about that, Brenda? Okay. All right. Will this be a test question on the next test? Guaranteed. Okay. All right. So,
And you said we don't have to memorize this formula.
you don't have to memorize the formula, but if you want to memorize the steps, you'll have to do that. Because I'll give you the formula, but I'm not going to give you the steps. Okay? All right. So now, have you ever heard the phrase that correlation is not causality?
Just barely.
Yeah, correlation.
Just barely? You just
I
barely
think I've
heard
heard
that?
of that before.
Okay.
My psychology or biology.
Yeah, so we're going to talk about some interesting things here. This is one of my favorite websites. I wish I'd have known this when I first started teaching. Tyler Vegan. Here we go. Spurious correlations. Okay. Now, one of the other interesting things about this website is it deals with nonlinear correlations. We are not going to deal with nonlinear. We're only going to deal with straight line. Okay. All I'm going to say is this is a straight line, and you can say yes or no. And if you say no, we're not going to do anything with it. But in this case, do you think there is a correlation between U.S. spending on science, space, and technology and suicides by hanging, strangulation, and suffocation? Okay. When the U.S. spends more on science, does it make you want to kill yourself?
It says.
That's what the chart says, right? Do you think those are really related?
No.
But the chart can't lie.
How about this one? Number of people who drowned by falling into a pool and the films that Nicolas Cage appeared in. Isn't that crazy?
Wait, it actually, whoa.
Wow.
It's like legit.
You watch a Nicolas Cage film, it makes you want to fall in a pool, right?
And drown.
And drown.
Nonetheless.
How about this one? Per capita cheese consumption and the number of people who died becoming entangled in their bed sheets.
What the hell? Really?
Isn't that spooky?
Wait,
800 deaths?
800 deaths.
It's mostly like infants.
Is that like a baby?
Yeah, it's gotta be
Do
babies.
you think those are related? Sure looks like it. Must be, right?
I need to stop my cheese.
Why is this increasing as we go, Jesus?
How about per capita consumption of margarine and the divorce rate in Maine?
So,
Do not eat margarine in Maine. You'll get a divorce. Okay? How about this one? The age of Miss America and murders by steam, hot vapors, and hot objects.
murders by steam? That's good.
The younger the Miss America is, the less likely you are to be murdered by steam.
Man, we need.
Well, let's get like a 16-year-old in there, come on.
Yeah, they should put an age limit on there. Can't be more than 20. Okay? How about the total revenue generated by arcades and the computer science doctorates awarded in the United States? Pretty cool. Okay? All right, so what I'm trying to say here is just because two things are correlated doesn't mean they're related. Okay? So that's kind of a fun website. Now, there is another one here. Oh, here's another one. Let me pull up this one. Have I told you about my favorite statistics website? 538.com. Okay? They really get into politics. They talk about politics a lot. You can see they track Donald Trump's approval rating, but they have a podcast and they talk about statistics constantly. The reason, how they got the name, there's a guy named Nate Silver, and in, let's see, 2012, there are 538 electoral college votes. He tried to predict how many Barack Obama would get and how many Mitt Romney would get, and he nailed it. Got all 538 correct. Perfect to the vote. And so that's how they came up with the website. He didn't do so well with Hillary Clinton and Donald Trump. But he actually got 46 out of 50 states right, plus the District of Columbia 47. But he said Hillary Clinton. Well, he was correct that Hillary Clinton won the popular vote, because she did. But he thought she would win the electoral college too, and she did. So anyway, that's where this website came out. But 538.com, if you're really into politics and stuff, this is pretty good. But they don't just talk about politics.
Talk about sports.
Talks about sports.
I just looked at it.
And he also talks about you can't trust what you read about.
Chance of winning finals, 1%, Jazz, heck yes.
Okay.
I got it.
All right. So he says that there's a correlation between cabbage and whether you have an any belly button. There's a cabbage between egg rolls and dog ownership. But anyway, this is a fun little thing to read. How about potato chips and higher scores in math? Eat your potato chips. Okay, so this is a fun thing about what you can't read, what you trust about nutrition. So just be careful. Just because two things are correlated doesn't mean they are strong. So there is an interesting thing here, though, that I will tell you. This is an interesting website. Jones.com. This one I actually believe might be a possibility, but I haven't done a lot of research on it. Is there a relationship between crime and how much lead is in your gasoline? This makes the case that yes, there is. You know, lead, and it's not just lead. They've taken lead out of gasoline. That's why I have unleaded gasoline. But there's lead in your paint. If you live in Flint, Michigan, there's lead in the water, which is terrible. I don't know if you've been following that news, but yeah, they got a new water source, and it was full of lead, and all the people who've been drinking the water are getting a lot of lead, and it actually lowers your cognitive function, lowers your intelligence, especially if you're a young child. And so they've done a study and they think that too much lead leads to people doing more crime. So that's kind of an interesting, but it's a correlation, so it's hard to say if it's causality, but it could be. So that's pretty interesting. Last thing I want to do, I'm going to turn off my video because I don't want to break any copyright laws, but we'll watch this in a second. In fact, I will show you the link here. Screen polio. Okay, so this is a fun little video here. Well, I'll pause this anyway. So I'm gonna stop the recording now. This is an interesting thing about correlation and causality.
At the workflow that suits me. When you're a
It's lots and lots of fun to have a pet. Run, play, and jump with his pets. But did you know there are some boys and girls who can't run and jump and play? It's all because of the thing called polio.
When I think of bad historical assumptions about correlation and causality, I think of polio 100 years ago, when it was this horrible mystery that it was, claiming a lot of lives, and it was really scary because it mostly struck children. And there was a strong line of research that suggested that ice cream caused polio, that ice cream consumption caused polio.
You ever heard that?
The reason that correlation was thought to be causal was that polio spiked in the summertime for reasons that really weren't very well understood, but it did. And ice cream sales spiked during the summertime. So these researchers had seen that whenever there was a lot of ice cream being sold and consumed, there was a lot more polio. And so there was really literally the beginnings of this kind of ice cream persecution to try to stomp out polio. And it sounds ridiculous, but you see it all the time now, people trying to fight against or build up something that they're sure is connected to something else, which it turns out just isn't.
Okay, I want to replay that again. I don't have to play the whole thing, but we are going to skip ahead to this graph here. So once again, I just want to point out to you a couple things.
Ice cream sales spiked during the summertime.
Okay, ice cream sales spiked in the summertime. That's an interesting comment that you made. Okay, so you can see here, this does seem to make a pretty strong case for ice cream causing polio. Do you guys know what causes polio?
No.
It's a virus. Okay. Now, so the interesting thing is, even though, so ice cream does not cause polio, newsflash, okay? But when do people eat ice cream in the summertime? And that's one of the things that they noticed was polio infections happen more in the summertime. What are some other things that people do in the summertime besides eat ice cream?
Swimming outside.
They go swimming. Swimming causes polio. When you swim in an infected lake or pond that's infected with the polio virus. It's actually a virus that causes polio, and it comes from swimming in infected lakes and ponds, okay? And so the interesting thing is, the scientists, they were on to something. There was something about summer, but it wasn't ice cream. But the amazing thing is, you could actually say, okay, we're going to run a correlation between ice cream sales and polio, and we will be able to properly predict how many polio cases there will be based on the ice cream sales, even though they're not related. Okay? So that's one of the interesting things is, so once again, correlation does not imply causality. Certainly ice cream does not cause polio, but there was a lurking variable going on there in the summertime. Okay? So that's another example of a lurking variable. So anyway, let's see here. Is there anything else? You know what, since we've got a few extra minutes, I want to show you another one. This one actually leads into chapter 5, which we're going to do next time. And I usually run out of time anyway. So I'm going to show you another video from Freakonomics that I normally don't have time to show. Here it is. This is it. Okay?
This is what the project This is what it looks like, and this is what it feels like.
Chance to see what the world would be like without you.
What I believe will be true, and I think evidence supports it, is a hypothesis which science already.
Oh, you know what? This isn't the whole thing.
I believe it's probably.
This is the short one. Well, this one will do it, but I'll just have to fast forward it. Oh, I don't want to pay for it. They cut out a lot of the stuff here. Well, we can watch that one, but it was the shorter version.
Right.
In 1973, in a case called Roe v. Wade, the Supreme Court ruled that abortion, which had previously been legal in only 5 U.S. states, would now be legal nationwide. Precisely the opposite of what happened in Romania.
The legalization of abortion in the 1970s was one of the primary reasons why crime fell in the 1990s. Because a whole generation of potentially unwanted children were never born because of the legalization of abortion. If you fast forward 20 years to the point in time when they were going to be at their peak crime ages, they simply weren't there to do the crime.
See, George, you really had a wonderful life. Don't you see what a mistake it would be to throw it away?
The trouble, of course, is that life isn't like the movies. For so many children who, without Roe v. Wade, would have been born in 1973, their lives might not have been the wonderful lives of being born into a loving family in yesterday's small town America. Rather, theirs would be a far harder road of being born into a potentially unwanted household in America's crumbling inner cities or forsaken heartland. Netflix conclusion, as much as half of the 1990s crime drop was an unintended consequence of Roe v. Wade.
Okay, let me stop this for a second. Oh, that's exactly where I wanted to stop it. Okay. We missed the first part of the video that I wanted to mention here. But basically, Stephen Levitt has done a lot of research in crime. So crime dropped basically under Bill Clinton. And so he was trying to figure out what are the biggest reasons for the crime drop. And what he did was he found out, well, we started putting more people in jail. And so 30% of the crime drop could be related to an increase in prison. 15% of the crime drop was related to differences in crack cocaine being distributed. And then 10% was between a strong economy, police increase, and other reasons. Okay, so 30 and 15 is 45, plus 10 is 55. So he was able to explain 55% of the crime drop. But the problem was 45% was unexplained. Okay? Now, and so he has made a case that he thinks that abortion might be a reason to explain what this unexplained is. It's only a correlation, so he can't say for sure. But the question is, how do you come up with these values here? So remember, so the idea here is if you take your correlation coefficient and you square it, R squared is called the coefficient of variation. Okay, so if we take there, the prison increase was 30%. So if your R squared is 30%, what's the square root of 30%? Somebody give that to me really quick on your calculator. R equals, what is it? -5. You don't even use your calculator when you got it? You gotta use your phone? Okay, it's 0.5 even?
Wait, no, it is.
Wait, I think it's 0.09.
Square root of 0.30.
Yeah.
It is 0.09.
0.30.
No, I think it is 0.5.
Okay. Wow.
It's 0.547.
0.547. So the correlation for prison increase is 0.547. Okay? Now, according to our numbers, is that strong, moderate, weak, or no correlation? We would call that moderate, and that's the biggest number we have. Okay? So the idea here is, yes, go ahead and use these values for the quiz, but realize that in real life, this is more commonly what you're going to see. Okay? That's the strongest correlation, and it's just moderate. Does that make sense? Okay? All right, so we've got about 4 minutes left. I don't know if you guys want to do another one of these just for fun, or not, or if you want to just go 3 minutes early.
You said you were going to show us the test.
Oh, I was going to show you the test. Let's do that instead. Okay? All right, so okay, so here was the breakdown. So the median score was 80.7%. The standard deviation was 11%. Does this look like a normal distribution to you?
No.
You guys are not normal, okay? All right, actually, it looks pretty good, okay? So, yeah, we got more A's, B's, and C's, and fewer D's and E's, so that was good. And this is what you want to do. So, way to study on this, you scared me last week, but keep studying that hard, okay? High score was 95, the upper fence was 118, the minimum score was 50%, lower fence was 41. So you can see here, this is the written test. The computer test was just a little bit lower, and then the overall. The overall is actually hot. The first quartile was better. So that's kind of but anyway, so there you have it. No outliers, so that was good. Okay. Any other questions you guys got? Standard deviation was 11.6%. Mean, oh, that's interesting. Notice the mean was lower than the median. The mean was 78 and the median was 80.7. Why do you think that was? Some of these scores pulled down the mean. Okay?
So how many people got the max of 95? Would you have to do a relative?
Only one person.
Only one person. Same.
Okay? But yeah, so 1/4 of the people got 89 or better. 1/4 of the people between 80 and 80, 1/4 of you got B's. That's really 70%, 70 to 80. 1/4 of you got C's, and 1/4 of you were below C's. Okay? So well done. That's one of the better scores I've had over the last few semesters, so way to study. But you got to keep it up because remember, every test gets harder. Okay? So keep up the studying. What you did was well. You did really good. Pat yourselves on the back. And keep it up.
When is our next test?
In 3 weeks.
Okay, 3 weeks.
Okay? Plan on the end of February, first week of March, somewhere around there. Okay? All right, well, we'll see y'all tomorrow. Quiz will be on chapter 4. And it's cool that I got to show you these videos because I usually run out of time.
So you want us to do all of, I was just confused because some of the problems on chapter 3 we didn't do, and then on the homework you said just to do 3.1 through 3.4. So I was just confused.
No, I said do the whole homework.
Okay, do the whole.
I even sent you an email to do the whole homework.
Okay.
Do all the homework for chapter 4.
Okay. All homework for chapter 4. Okay.